Hello.
Hello, everyone.
Oh, yeah. Hi. So, what is Massa?
Hello. I will present a bit Massa and also maybe a bit myself. Massa, it's a blockchain, a layer one blockchain that we are currently building since a few years that we start the research and also development of the blockchain. We are in testnet since more than 1 year, but it will end soon. And the key, like the main principle of Massa is to push for the decentralization, but also to not forget about security and scalability, because we think that the blockchain is by essence for the decentralization. Otherwise, there is no real point to use a blockchain. And it's something that has been a bit sacrificed in the last years for the scalability problems. And so we are pushing really for the decentralization, but we also have a totally new architecture of blockchain, which is threaded with transaction sharding. You can check out this on our website, but that allows us to also have a good scalability and security. Also, of course, for blockchain shouldn't be like we have to think about it, and we have to be secure to avoid any problems. That's mainly the triangle of Vitalik, the creator of Ethereum, that is saying that we can't have fully decentralization, fully scalability, and fully security. But we think at Massa, even if we point towards the decentralization, we can achieve a really good scalability that is enough for a world use case. And like you don't need to have millions of transaction if the visa system only have a few thousands. I think we can achieve the scalability that is enough for using our product in real life. And so that's what we are building at Massa. And we are pushing decentralization not only on the like token distribution or node running. We are pushing on this side also because we are making a node that is that we want to be able to run it on really low devices so that anyone can participate. Because if you have an entry ticket of multiple $1,000, it can't be decentralized because not everyone can participate. And so that's one of our goal. And also on the other goal, we also want to push decentralization on the smart contract and ecosystem side. For this, we have think about how we can engage more developers on our ecosystem. That's why in Massa, our smart contract I fully written in TypeScript, in assembly script to be precise, but which is a subset of TypeScript, but mainly all features of TypeScript in it. So if you are just a developer that knows JavaScript and TypeScript, you can develop your front end and your backend with smart contract on Massa and fully create your DApp. So that's something that will help the decentralization of the app.
And what did you call that script? You said it was a subset of TypeScript?
It's assembly script, which is a language, which is a subset that compiled toward WASM, and we use the WASM bytecode that we store on the blockchain for smart contracts. And so that's thing that we want to push forward. And in our smart contract system, we also sort out some problems that create centralization in other blockchain, like the fact that sometimes when you want to have a trading bot or something like that, you often deploy a smart contract on the blockchain and have a centralized bot on your server. And so this creates a centralization point, and we want to avoid all centralization points. So we deeply research on that, and we found a solution with something that we call autonomous smart contract, which is a way for our smart contract in Massa that are deployed on the blockchain to be able to call themselves in the future, saying, okay, maybe in 2 days, I want to call this function myself with this amount of gas, etc. And so the smart contract fully on-chain call himself in the future, and you don't need a bot anymore to call your smart contract periodically. So that's something also that we want to push. For example, we also host our website on chain, so you can directly host your front end on chain. That will prevent, for example, hack of front ends, or also that your front end is forbidden on some countries because you are making a newspaper that is not well seen by the government, so they block your website. But if the website is hosted on the blockchain, they have to block all the nodes of the blockchain, which is far more complicated. And so we like think about all these centralization points and how we can break them. And these two features of autonomous smart contract and web on chain, that the two features that we will focus on today, and with the little live coding I will do just after.
Very cool. And what do you do for Massa then? What's your job there?
So I joined the company 1 year and a half ago as a developer, and now since 6 months I'm in charge of the core team, which is the team that is developing the core node in Massa. So the node is the software that you run to participate in the blockchain as a node runner that you use for staking, etc. So yeah, we are keep building this node, and we are on the finish line because we are on the end of the test nets very soon. We have a few months left. And so we are trying to push the last features and to stabilize everything ready for the big launch.
Cool. And this is all open source, I assume, right?
Yeah, totally. I will showcase after on GitHub the repository that we use today, but you can check out all the source code of the node or of our smart contract system directly on our GitHub, Massa Labs, and you will have everything. We don't have any code private except some simulation tool and benchmark, etc. But all the code that is used to run your smart contract on the blockchain, etc., everything is totally open source, and you can check it out yourself. The node is written in Rust, and the smart contract system is in assembly script, and we have a library in JavaScript also that I will showcase. But yeah, everything is totally on our GitHub. You can also contribute if you want, even if sometimes there is a bit of entry barrier to contribute, but we can help you if someone is willing to contribute.
Cool. Thank you. Well, do you want to go ahead and get started then? Show some code?
Clearly. So yeah, today I wanted to showcase, so as I said before, the main two features of our smart contract system. Just open a bit the window because, or maybe, do we hear the rain? Oh, it's okay.
I don't think so. Yeah.
Okay, nice. I can open a bit because it's getting hotter. So yeah, we are.
Yeah, you're in the south of France, you said, right? So it must be pretty warm
south
there,
of
right?
France, but there is rain outside, so I don't want to make noise on the sound. But it should be okay.
I think we can all tolerate noise. In fact, my computer has such a loud fan; it probably sounds louder than rain.
But we don't hear it, so it's okay.
Okay, good.
So yeah, I want to showcase these two features about autonomous smart contract and hosting web on chain. To do that, I will showcase a real world use case, which is focusing on DeFi and especially a trading bot. So in Massa, we have a decentralized exchange that is currently building, and there is a public beta, I think, that is running now or just ended. I'm not fully sure. But this DEX will be released in the mainnet. This DEX is called Dusa, and this DEX includes some new features that hasn't been included in other DEX because of thanks to the autonomous smart contract system. They can provide DCAs and things like that. So it's really interesting. And so today we will build a trading bot on top of this product using their interface in smart contract, and we will see him trading a pair of tokens directly on the Dusa DEX. And yeah, so I will just share my screen to give a bit more context. Okay.
There we are.
So yeah, this is the Dusa interface that we will use today. So we have a pool of tokens, which is a pool with Massa and USDC, a pair with Massa and USDC, and the pool is distributed like this. We will not go in full detail because I'm not a financial guy, but it's a pool that is with a bin system. Sorry. So what is the difference between a bin system and a linear system? It's just often like the pool, for example, in Uniswap works with linear system when you buy some tokens of one of two of the pair, the price goes up or down linearly. In the bin system, like you have for example, a bin for a price of 20 USDC for one Massa, which have this bin have a size, and when the bin is empty, then the price goes to the other bin. So it avoids to have too much impermanent loss, but it's a bit technical to DeFi, so I will not go in detail. If you want to check out, you can check documentation of exchanges that use this. For example, Trader Joe, I think, used this way of making the pool, and they have good documentation about this.
Right. So just for people who don't follow DeFi closely, we're looking at a liquidity pool here where you have contributions. People are providing liquidity for both the Massa token and the DP token. And the bins are, you said, mitigating against impermanent loss, which, like, even before that step, I guess what they're doing is they're mitigating volatility in the price as trading occurs.
Yeah, and like to explain a bit the interface that we will see during this call is that on the left you have the prices that is lower than the current price. The current price is 25, and on the right you have the prices that are bigger than 25, and so this is the middle point that we are currently at with the current price. That's everything that we need to know for this call.
Cool.
So I will use some cool tools that we have in Massa and our smart contract system. The first one is the toolkit, something that we call the toolkit, which include a little project that is called the SC Project Initializer, which allow you to have a full template of a smart contract that you can use directly and edit to create your first smart contract. I will use it just after. And so it creates you a sample contract, a file to deploy it directly on the blockchain, some unit tests, etc., so that you have a full environment, not only a little source code file that you have to sort out yourself how to use it. So that's really nice for newcomers. I encourage you to check out this repository, and we will use it just later. As I explained just before, our smart contracts are written in assembly script. And so we have a little library in assembly script that allow you to interact with the Massa node. So you can, for example, make transfer of money, call smart function from other smart contracts, get some interaction with other addresses, read their data, etc. You have a full documentation on the README also that is available, that we will look at it during the live code. And so we also have, like many other blockchain, a library in JavaScript, TypeScript that you can use to interact with the node and also the smart contract world directly on your website or on any things that is code in Node.js, JavaScript, and TypeScript. And you have a bunch of methods to interact with the API of the node and also directly with the smart contracts, etc. So that's a module that we use.
So that's basically the client library for your web application.
Yeah, exactly. That we'll use also today. I will not code directly the interface in live because it will be too long, but I have made a little one right there where we'll be able to see our bots directly playing on the blockchain when we develop them. And so this interface uses the Massa Web3 library. And also we have the last thing that is named before Sula, which was the project name internally, but now it's called Massa Station, which is the entry point to the web on-chain on Massa for now, but later on will be like a full set of like little plugins or little product that you can run on Massa. For example, so there is the web on-chain, but you can also, for example, in the future, we want to provide something that you can run your node directly there with one click and some configuration that you will need to make. We can think about all different products that can be built on Massa and directly be accessible on this platform. And this platform is is running on like it's a software that you run on your computer, and the interface is directly embedded on your browser.
Okay, so let me clarify that one, and maybe just run through all of the stuff that you said. So web on chain, what you're talking about here is the fact that in all other chains, in order to deploy a DApp or a decentralized application, you typically will deploy it to like a centralized service, even like AWS or Google, just like you would in Web 2, because there is no way to decentrally, I don't know if that's the right word, but you know what I mean. There's no way to host your web assets, which are static assets like HTML, JavaScript, CSS, on the chains themselves. But with Massa, you've created a way to both host on-chain and create this sort of like DNS-like domain system that is also decentralized, where you have .massa domain names. But in order to do it, someone has to run some sort of a node that resolves these things, and then maybe like proxies to an HTTP server running on the Massa nodes. Is that right?
Yeah, you can use a node of someone else if you don't run your proper node, but this is connected directly to a node of Massa. And for example, if I access to one website directly on my browser, this works like a real website. We think that we are really on the internet, but in fact, all the .massa websites are resolved by the software that you run on your computer. And instead of asking the code to the internet, it's asking the code to the blockchain directly. So for an user, there is nothing that changed because it's directly on his browser. He don't have to change his attitude or things like that. He can stay as usual, as he used for now his DApps. But in decentralization, for the decentralization and the security, it's much better because you call directly the blockchain and the code of the website is on the blockchain. So
right. It means the code is also immutable and traceable.
Exactly. Yeah, it prevents someone to gain access on the centralized AWS, like you say, and change the smart contract address to point to his smart contract and steal of the funds of someone using the website. That's not possible when you are hosting the website on the chain. Otherwise, you have to hack the chain herself. So that's more complicated.
Cool. Yes. Hopefully.
So yeah, that's the dream, but we will go through them one by one during the presentation. So the goal, will be to develop the trading bots directly with everyone on live. So as it will start by the interface, I already made it myself, but we need to code the smart contract of the bot that will interact with Dusa and buy or sell some Massa depending on some conditions. So if we want to create a new smart contract project, we will go in our toolkit that will allow us to create our new project. And so we can take the command that is on the markdown file on the repository, launch a new terminal. Maybe I need to put more bigger this. And so, we can provide the name that we want for our project. So I will call it demo, for example. It takes a little bit of time just to install every little packages that we use, not that much. And now we can open with our code editor the demo folder. And we have a bunch of files on it. First of all, we have a nice README that is explaining us what's going on, how to use this repository, how you can deploy your smart contract directly on the blockchain. So in the repository, there is an assembly folder with a contract folder where you have a main.ts. So that's the file in assembly script. Maybe I will just put it in here. Yeah, so this file is a smart contract, a simple smart contract that we provide when you use the templates. And so there is a constructor function that will be called when you deploy using this template. When you deploy a smart contract, this constructor function will be called directly. And so it allows you to set up some kind of things on your smart contract without having to make some permissions in the future or something like that, or even deploy a smart contract that is not fully initialized, this function is directly called when the smart contract is deployed on the blockchain. So that's really interesting. To initialize some variables like the name of your token or the liquidity that we have at start, the decimals, things like that. And
similar to a normal object-oriented language. It's sort of like your instantiate object.
Yeah, that's why we choose the name constructor, because it's clearly its job, the job of the function. And so you also have a .env.example, because it's just an example of a .env, but you can use it, add your proper data and use it. You need to add your private key so that we can use the folder, the script of deployment can use your account on Massa to deploy the smart contract directly on the chain. Here you choose to which node you want to talk to deploy your smart contract. So if this is our node at Massa, but if you have a node on your side, you can change by your local address like this, for example.
Yes.
But if you don't have locally. If you don't have a node on your side, you can use our node to deploy directly on the blockchain.
And is this the one we should use now? If I were to do something today and I'm not running a node, I should just use test.
Yeah, clearly. This is like the one on the testnet, but if you wanna develop some cool smart contract, I think we have a network that is currently being set up, which we will call BuildNet, because on Massa, on the testnet of Massa, we are providing updates each month. And so it's really, really often for builders each month. If they need to update their code each month, etc., it could be very heavy for the builders. And also each month we have a downtime of 2 or 3 days to make the update. So we are currently building to create a new network that will provide to the community, which will be called the BuildNet, and I will use it on this call. This network will not restart every month and will be on a fixed version of Massa for multiple months, so that the people can build directly and have one update each 4 or 5 months. I don't really know. It's not determined yet.
Right. But so it should feel like production, except the data isn't the same because it's a different blockchain.
Like the BuildNet will be, it's like a test net, but just for builders. The goal is to have the full ecosystem running on the same blockchain, because right now some people are testing on their side because the testnet is not already running, etc. So we want to group every project on one network so that they can interact with each other, etc. All the addresses for this network will be communicated, I think, in a few days, but we will use it directly in this call. But this is the address for the testnet, network, and when the mainnet will be released, there will be an address for the mainnet node also, of course. So that's the 2 main things that there is in the folder that you need to edit. The last thing that is nice to edit is the file that actually deploy your smart contract. So there is a bunch of things to retrieve the data that you provide in your .env, but the interesting part is that you can here deploy the smart contract that you want. So you have to provide the path to the WASM version of the smart contract. So the smart contract is developed in TypeScript and after in AssemblyScript, and after there is a compilation phase which turn your smart contract in AssemblyScript to WASM, and this is this WASM that will be provided to the blockchain. So you can directly provide the path to your WASM and some coins that you want to give to your smart contract, some arguments. We will not go in details on arguments today because it's a bit complicated and we will not use them. But here you can add another smart contract if you want, or modify the smart contract, how much coin you want to send. And just with these 3 files modified, you can fully create your own smart contract project, and you can npm run build to build a smart contract and npm run deploy to deploy it on the blockchain. Just 2 simple commands like that. We want to provide an interface, a graphical interface in the future, but it will be in the more later future, like we have in Ethereum or things like that. But for now, we try to keep it simple as possible for developers.
Yeah, it's very familiar, even if you're not a blockchain developer, if you're just a JavaScript developer.
Yeah, clearly.
You know what to do.
all the JavaScript developers around the world know npm and know .ts extension files, and so they are not lost when they come there. That's our goal. Our goal is that someone which is used to build the Web2 application come in on our tooling and is not lost. He's like, okay, I understand what's going on. Maybe you don't understand all the details about what's going on when you deploy, etc. But he can start doing something and trying some features without having to learn all the deploy process, how to deploy an API of a node, etc.
Cool.
So I have made a little more advanced version of this folder for this call. So the skeleton. Yeah, I was searching for the word. Yeah. The skeleton is the same one as the one that we previously saw. Just the difference is that we have a bunch more smart contracts because this is all the interfaces that are provided by Dusa that we'll use to interact with their DEX on the smart contract world. So they are not public yet, I think. But this is just interfaces. They will, I think, release an SDK or something like that. They will announce it themselves. I will not speak for them.
Okay, so Dusa has a separate team that's building a decentralized exchange on Massa.
That's not Dusa, the DEX that I just showed and that we will use this one. It's not a DEX that is built internally in Massa. It's built by a company called, I think they call their company Dusa Labs, and it's a team of developers that we met at the first hackathon we made in Lyon in France. So it was, I think, 6 or 7 months ago, or even more maybe. And we made an hackathon on Massa there, and they won it. And so we was willing to continue with them. They was also happy to continue with us. And so they are now building the DEX on Massa. So it's a very nice story that we can have developers on our project of our ecosystem that we met at an hackathon. It's really, really nice. I think that's people that are really interested in Massa and that really think that that Massa can provide some cool features to DEX. That's why they want to keep working with us and make the DEX for Massa. So yeah, that's a totally separate company, but we discuss often clearly. So that's the same folder as we saw just before. Just they have at Dusa they have a full smart contract system which is fully built and have all the features. They just export some interfaces so that we can call their smart contract, and that's what I have imported on my folder there. We will not go in how it works. But this is why I have made this before, and I'm not using the one that I just showed you. I also set up the things that I explained before with the private key that I will use to deploy, and also the address where I will deploy. So this address is one of the address of our network, BillNet, that will be announced soon, where you can deploy all your smart contract with all the others projects built on Massa.
And the private key, did you create that on the Massa website, the wallet, or how do you do that?
So the private key, there is multiple ways. So if you want to create a private key on the testnet, you can use the Massa website. But for the BillNet, you have to... for me, I have to use the Massa client, which is a little binary that we have in the Massa node folder. And give him the IP of the BillNet, but I think they will provide a more easy way to create new addresses on the BillNet. They will provide the full workflow about it in the announcement of the BillNet. But if you want to test on the testnet, you can create your address directly on the website. And if you want to test on the BillNet, you can use the Massa client with all the commands described there, and you have a command to generate a secret key. Cool. But yeah, that's something that is not fully released public yet. It's just another network linked close to the testnet, but that don't restart often like the testnet. So this was the folder.
Probably worth saying you wouldn't normally share your private key on a
clearly that's a private key that I created for this call, and it's on separate network. It's not my private key on the testnet. That's something that I have made only for this call. There is some coins on it, so if someone want to take them after the call, you can, but it's coin only on the buildnet. They don't have any value. And clearly do not share your private key. This file should stay should always stay on the local of your computer and not be shared. Don't push it on your GitHub or things like that. That's just special for this call that I showcase there. Clearly, nice point. So we have the same little piece of code that was provided by the repository that we just had when we used the template just before. I just renamed the file a bot instead of main because we will create a bot. And so we can directly start working on our bot. There is multiple steps that we will need to go through before having a fully running bot fully autonomously on the blockchain, because the goal is to have our bot fully autonomously running on the blockchain so that when we will deploy it later on the call, we will be able to see him running himself on the blockchain. That's really, really, really nice. So first of all, we need to provide him some coins. So for the simplicity of this talk, I can mint some coins directly to my address, which is something that you cannot usually do. Otherwise, you have to be like the admin of the coin creator. I have also made a little smart contract library that I will use today where I have defined some addresses for the smart contract of USDC, the smart contract of WAPMAS, some function to get the price of WAPMAS. So I call it WAPMAS, but it's Massa. So I have made some function to get the price of Massa, to sell some Massa, to buy some Massa, so that when I will show you right now, it will be easier to understand the code of the smart contract. But you will be able to find the full source code directly on our GitHub. I will send you the link just at the end, so that you can, if you are interested, you can go through in exact detail what's going on. But for the presentation, I will just showcase some function that I have partially coded. The first thing is to give ourselves some USDC and some Massa. So I will import, I will use the address that I have defined on my little library, which is this address, which is the address of the USDC on the BuildNet network. And so I can provide this address to an interface, which is IERC20, which provide me some cool features like total supply, balance off. I have a bunch of functions that I can call, and the one that I'm interested in is the function mint, where I can mint an amount of token to a specific address. So I can write USDC.mint, and I want to give the token to myself. So myself in the smart contract world, this smart contract will be deployed to a random address when we deploy it. So we cannot write an address in a string format directly on the smart contract code, because the smart contract can be deployed multiple times and to different addresses. And we don't know in advance what will be the address where it will be deployed. So we can use a function that we provide with our Massa ASSDK package, which will be it will be replaced when the smart contract will be executed, when the function will be executed. This context.collie will be replaced by the address of the smart contract. So you can see that the collie function returns the collie address. Collie is the current smart contract address. So right now we can mint some tokens to our smart contract address, and we will mint, for example, 100,000 USDC. And I will also multiply this by 1 unit, because when you mint a token, like in Ethereum on other blockchain, all tokens have a decimal parts. And if you just say I mint 1,000 USDC, it will mint a fraction of 1 USDC because it's on the decimal parts. So you have to multiply by the decimal to have real coins directly. And I will also mint some Massa. So let's do the same thing. I have called the function for Massa wrap mass, and I will mint also maybe a little bit less because in the mainnet 1 Massa costs 20 USDC. That's not the price when the mainnet will launch. It's just on the mainnet on the full test. But so that equilibrate a bit to balance. And
so this raises an interesting question for me. Massa is not an EVM compatible chain, but I see you're trying to incorporate some things that would be familiar to Ethereum developers. For example, you have this interface called ERC20, which I assume is the same interface as the ERC20 in Ethereum.
Yeah, exactly. So we have a standard for fungible and non-fungible token, which is available on our GitHub on the repository Massa standards, where we provide the standard for the fungible and non-fungible token. But yeah, for some people of the community and also us before have implemented an ERC20 interface that is fully the same as the one on Ethereum, so that if people want to create a token that is ERC20 compatible, like it's the same interface, this is the same function that you can use. You can use the balance of function, etc. You can on Massa also. This is not it's not because that we are not EVM that we can't have the same interface for the tokens. Just internally, we provide our fungible token interface that is very close to the ERC21, but I think there is few differences because we have more features like the autonomous and things like that we want to provide on our interface of token. But for this call and to not lose people that are used to blockchain, I will use the interface of ERC20.
Cool.
So yeah, I can also give. So also I need to give the rights to the router of the DEX to use my coins. So I can also use an interface that is provided by Dusa, which is iRouter, and I can give him the address of my router. And I can say that I want to allow the router to be able to spend my coins. And I give I need to give, no, sorry, it should be increase allowance. And I need to give him the amount of token that he can use. So I will place like 1 million. So he can use 1 million of USDC. And he can also, it's not my tokens, it's the token of, like, it's not, no, I explain. It's not that he can use my tokens, but he can use more tokens of USDC and Massa. That's just for the sake of like working with Dusa. It's not really important. And we can also use something that is really nice on Massa. We can make some logs on our smart contracts that will be displayed on, like, not really displayed, but that will be saved when you execute a smart contract. So you can say that you want to generate an event. So that's what we call an event in Massa. You can use our function generate event, which is defined on the Massa ASSDK. Generate event, which is a function that allows you to create an event which is in format of string, and this event will be able to be fetched with the API of a node from the outside of the smart contract world. So, for example, on your interface on your website, directly you can retrieve these logs that has been produced by your smart contract from outside of the smart contract world. So that's really interesting to send some data or some information. For example, we can say that our bot has been deployed, for example. So we can place this log, and this log will be stored on the node when the smart contract will be executed, and we will be able to retrieve it with our interface. Sorry. So now we have initialized everything that we need. I will maybe just go downstairs a bit. And we can, if we want, we can try just to deploy this smart contract to test a bit how it works. So I have my deploy.ts where I say that I want to deploy my bot smart contract with 3 coins. I have set up my private key and the IP where I want to deploy it. So I can run npm run build.
And the deploy.ts was auto-generated, but you changed the name of the WASM file in it.
No, the deploy.ts is auto-generated when you use the template,
right.
When you run the template, but after you have to edit yourself. If, for example, I rename my smart contract to another file, I have to change it myself there. It's not fully generated, and maybe something that we can improve, right? It's a good point. So I can now deploy the smart contract directly on the blockchain, and we will be able to see if the smart contract has been deployed, because the deploy command behind the scene, it deployed the smart contract on the blockchain, but it also retrieve the event that has been generated. So we can see that our event bot1 deployed has been sent on the blockchain. Our operation transaction has been included on this block. This is the ID of the operation. So in Massa, the transactions are called operation, but you can transpose it to transaction in other blockchains. And yeah, because like call a smart contract, execute a smart contract, transfer money, buy a role, sell a role are all operation in Massa. And so they have the same I structure, just the content change. So yeah, we can see that our smart contract has been deployed, but like right now our smart contract is not doing anything apart from he has a balance, he has a lot of money, that's nice, he's rich, but we want him to be even more rich by trading. So we will create a function that will be triggered each half of a second, because in Massa the little, I don't know if we can say littlest, but the
smallest.
The smallest. Yeah, thank you. The smallest time frame, it's half of a second. So you are able to run your function autonomously each half of a second. So we will create a function that will be run each half of a second. So let's define a new function. We will call it, for example, advance, because it will advance in the time. It will advance the time machine, that is like the state machine of our smart contract. Here we define the arguments that our function take. We will not go through this, but we always take a byte array so that you can set whenever you want. It's not static range, but it's static array. Okay. So in this function, we wanna try to fetch the price. The version that we will make in this call will be a really simple version, where we will just buy or sell some Massa depending on the price. So we will, in this function, try to fetch the price. And if the price is, for example, lower than 25, we buy some wrap mass because it's really cheap. And if it's more than 25, we sell some wrap mass. So to be able to get the price, I have made a function, so we can use it in this smart contract, which will be get wrap mass price. Sorry. So we have the price of 1 Massa in USDC. We can even my Copilot extension propose me to generate an event with the price, so we can generate an event if you want. And so we want to say that if the price of 1 Massa is lower than 25, we want to buy some wrap Massa. So we can buy, I don't know, for example, we can buy 500. And we can also generate an event to say that we bought some Massa, so that we can see it on our website. And if the price is more than 25, then we will sell also some Massa, so for example 200, and we can print that we have sold some Massa. So yeah, that's
the purpose of this bot is to earn money while you sleep. by
Exactly,
buying low
but
and selling
a
high all
simple
the time.
algorithm like that will not earn much money. Otherwise, we will all be millionaires, and we will not be there to talk together. But yeah, we will see a little improved version of this bot with the RSI index. Just after I will showcase something that I have made. I will not have the time to go in detail, but the code will be also on the repository.
Okay.
But yeah,
Let me ask you a couple of clarifying questions then. This advanced function, is this something that is automatically called by the chain if it's defined?
No,
Is that how it
for
works?
now,
Okay.
the function is not called by anyone. We need to add the logic ourselves to call the function each slot. So for now, the function is there, but nobody calls him. We can call it from a call smart contract like in other blockchain to make it advance each slot, but we will need to have the famous centralized bot that will call the function each half of a second. So we will need to add the logic to call the function each half of a second just after. So I have made a little wrapper function which is called call next slot. So a slot in Massa, it's a point in time that is each half of a second. So we will call this function in the next half of a second. We can define in what address we want to call the function, which function, with how much gas. We have even more parameter on the real function on the ISSDK that we provide. We have the list of parameters that you see on my screen. I will not go in detail of all parameters. That's why I made a little wrapper function for this call. But if you want to check the documentation on the Massa ISSDK, you have a bunch of cool features that you can add. For example, you can add a range of validity. You can say, okay, I want to wake up my smart contract between this time and this time. And if, for example, you can say, okay, I will wake up him in 2 days or 3 days, and at maximum in 5 days, because maybe your smart contract will not wake up in case of there is too much contention on the network, because it works a bit like operation. There is some kind of ranking, and not all messages are executed. Not all smart contracts are executed, but that's complicated. And you can also, for example, say, okay, I want to trigger my smart contract only if there is a change on an address or on anything that is stored on an address. So, for example, you can have an address that is storing, I don't know, the price of a token, like the price of Massa, and you can say, okay, I want to wake up my smart contract only if the price of this token has changed. And so you are not defining when in the time you want to re-execute your smart contract, but you define on which condition. So that's really powerful. You can make some really nice and complex things with this little function that have a bunch of parameters. But in this call, we just call our smart contract each slot. But I would just want to precise that you can call it more on the future, not only in half of a second. And you can also call it on the condition of something that is stored in another address on the blockchain. So
yeah, the latter thing is one of the most interesting things I've heard about Massa. That like time is certainly interesting because you can't do it with other chains, but
yeah,
you're basically creating an observer type situation where you can react to events on chain in your own smart contracts.
Exactly. That's really something that, and even you can call function from other smart contract. Like you can say, if the price I change on this smart contract, I want to call the function on this other smart contract. You are not forced to call the smart contract. Let me explain it better. You are not forced to call the function of your own smart contract. You can call the function of other smart contracts that can themselves do another function extra. So that's really, really powerful. So in this simple example, we will just call our proper function. So the address will be our address, context callee, and the function will be advance, the function that we are in. And we will call it with some gas. So we can place, I don't know, 700 billions like this. Enough gas to be sure that it works because the gas is free on the billnet. So yeah, so right now, if we deploy it like that, and we add some, if we call the first time the function on the constructor function of our smart contract, like the constructor function will be called at deployment. If we call the function advance directly on our constructor, this will call the function and get the price of Massa, see if it's less or more than 25. In this case, buy or sell some Massa, and then call it again in half of a second, etc., etc., etc. And here we have a little problem that we don't have any stop condition. And so our smart contract will just run himself forever as soon as he has enough money to pay for the gas. But the gas is free on the billnet because there is only me right now, which is playing on it. So the network is nearly empty. So it's totally free. So I will just run my bot forever. So I need to place some kind of stop condition. And for that, we can use a cool feature that we have in Massa is the way that we are storing some data on each address. So a lot of blockchain I've used different way to store some data for each address. In Massa, we choose to use a data store that is key value. So for each address, you have an infinite data store where you can save a key and a value, like a little bit like the local storage on your browser to be a bit compatible for the one that came from the Web 2 and things like that. You can set up a key and you can set up a value, and you can retrieve this key and this value in the future because it's stored on your smart contract. You cannot store an infinite amount of data because each time you store some data, you pay a little bit. You are not really paying. You are placing some coins locked for the storage that you use. And when you release the storage, so for example, you delete the key from your storage, from your key pair storage, you will retrieve the coins. We use that so that we can limit the size of the full storage of all the addresses to a certain amount, because if you are placing some coins, some lock coins when you ask for storage, if everyone places all the coins, it will reach a maximum that we fix to 1 terabyte, so that it's avoid people to need to have multiple disk to run the Massa node, and they just need 1 terabyte for sure and forever because it's limited by the amount of token on the network. So,
so who has access to this storage? Yeah, is it just the owner of the contract?
Yeah, exactly. That's just the contract that have access to it. For when you deploy the smart contract, when you deploy the smart contract yourself on the transaction, when you deploy the smart contract, you have access to the storage of this smart contract. But that's the only moment on the whole Massa blockchain that someone else have access to the storage of someone else. Otherwise, it's just yourself that have access to your storage. So you can save some data, but you only yourself have access on write, but everyone can read it because it's on the blockchain. So everyone can read your storage, read your keys. If you know how you serialize them on bytes or things like that, you can retrieve the data that you stored. It's not private because it's on the blockchain. It's totally public. So we will create a function that so the goal will be to save some data on the storage in a key called, for example, counter. And each time we call the function, we increase this counter value. And when it reaches a value, for example, 100, we stop the calling in loop so that the bot stop at a certain time. So I will write a function that will be named start. That will be the function that will start the bot. So this function will just use the storage to set up the counter to 0. So we have the storage object that is provided by Massa SDK, our packages, our SDK in assembly script. So as you can see, there is a bunch of function. We will use the set one, which takes a key and a value. So you can provide it either in string format, args, or bytes. So to simplicity, we'll provide it to in string format. So we will provide a counter key with a value of 0. And we will call the advance function there. We will not call it like there. So when we will call start from our interface, because from the interface we can call function on the smart contract, like in other blockchain, you can call the function that exists on smart contract that are stored on the blockchain. So we'll call the start function, and the start function will set up a counter value to 0 on the storage, and then call the advance function. And in the advance function, we need to place some logic so that we will stop when the counter is too high, and we need also to increase the counter. So first of all, we will retrieve the counter value. So we want to retrieve it in number.
You're retrieving the string value and converting it to a number.
Exactly. Yeah, I use the parsing method.
And to be clear, I assume the keys in these are scoped to the smart contract, so you can't overwrite someone else's keys or have collisions outside the contract.
Yeah, exactly. So you have access only to your storage in write access. So you cannot write on someone else. When we say set, it's set to your address. If you want to set to an address of someone else, in specific case where you have write access, you can use set off, but you have to have write access to the address where you want to set the key. So yeah, when you use set, you override your proper storage. Everyone can have a counter variable, and you will not override the one of the others. So right now we have our counter in format of a number, and we can say that we can increase our counter each time we run the function, and we have to save again the counter on the storage. So we use the set with the same key counter to save the new value updated. And at the start of the add-on function, we want to set a condition so that if our counter is more than, I would put a little bit more, like 300, we can return and quit the function without calling in again. So if we have a counter that is more than 300, it will directly return and not trigger this whole bunch of code that should call the function in the future again and again. We can also write a little function stop that will allow us to stop the smart contract before waiting for 300 multiplied by half of a second. We can set directly the value of the counter to 301 so that it will be too high, and when the function will be triggered, it will return automatically. So this is a simple way to stop your autonomous smart contract. And I think that's a basic smart contract that we can use on Massa. So let's try if I didn't made any compilation mistake. Let's build the smart contract to see if there is any bug. Okay, so no, that's nice. I have made great things. And now we can try to deploy it. Maybe we want to, no, we don't need to write any more logs, any more generate events. That should be good. Let's try to deploy it on the blockchain and see what happens if it deploys well. So right now, when we are deploying the contract, the function that will be run is just the constructor one. So the constructor doesn't call the advanced function. We will have to call the start function. That's why we will use the interface that I have made to directly call the start function.
Yeah. So back to my question earlier, the name advance is completely arbitrary. It's just what you chose. You call it whenever you want, and then it itself schedules itself again by talking to the Massa scheduler. Yeah, that's nice.
It's just the fact that you use the function on our SDK that allow you to provide like loop to your function, like provide the fact that you can call it in the future. When you use this logic, you can use it on every function that you want on every smart contract. There is no naming convention. So I have added the address to the interface so that if we go, so this interface is a little interface that I have made for this presentation. That's why it's not fully fancy because I'm not a front-end developer. But we can see.
I think it's pretty fancy. I say good job. Very fancy.
Okay, thank you. We can see the balance of each tokens of my bot. So 100 USDC and 40,000, 100,000, sorry, and 40,000 Massa.
You're seeing every tick in time as the chain progresses too. Is that right?
Yeah. Like so yeah, well, we see this is real time data. So you can see that the slots is each time frame. So each half of a second, the balance is updating, and we will see our bot update is balance of each token when you will make some swaps. So we can try to start the bot and see what happened. So let's click on this button. We will have all the debug logs that will be right on there. So all the logs that we provide. So yeah, we can see that our bot is running. We can see that the balance there is making up and down, up and down, up and down. Why? Because as the condition is just that if the price is more than 25, then we buy. If the price is lower, then we sell. Then the bot is just playing himself on the pool and just buying and selling the same token. So there is not much. There is nobody else that is making some swaps on the pool, so it don't earn or lose anything. But at least for now,
because we're just in BuildNet and no one else is using it, right?
Yeah, but just you will see that I have made a little thing that will use it in the same time, so that we'll be able to see it. So, but for now, we can see that the logs work well. We can see that the log that we wrote on our smart contract are fetched by our interface. So if you want to see how we fetch this in the website world, etc., everything is on the repository that I will share after. And so we can see that the price goes up when we buy some Massa. The price was below 25, and when we bought some Massa, it goes up after 25, and after we sell some Massa, and it goes down, etc., etc. So that's working well. Right now, I will just stop it. Maybe I will redeploy one. If depends on where it stopped of its parent. Okay, so we stopped it. We will run something that I have made just before the call, which is a little smart contract that is making some price variation. So it's a smart contract that randomly buy and sell some tokens on the pool, so that it simulates that there is someone else on the pool that is making something, and we will see if our bot will crash and we will go bankrupt, or if our bot will make us rich. Let's try to see what happens. So we have some logs about the debugs, but what happened if the debug script, so the debug script, it's the simulation script by ourselves. So for now, it seems that we are getting some money, but we can see that the price is not only going up and down because of the bot, because there is someone else on the pool, and our bot is trying to buy when it's cheaper and to sell when it's higher, and is making a good amount of money. I think we will be able to go on nice vacation after this call.
Maybe we can go to the south of France on vacation.
Yeah, no problem. So yeah, that's something that is a real world use case that we built fully on Massa. The last thing that is not on Massa yet, but I will just showcase after, is that our website is still on local and is not hosted on the chain. That will be something that we will resolve just after. But on the backend side, everything is fully on chain. We have no centralized bot, nothing. Everything run on chain. Like all the backend is on chain. That's really powerful, and we can see it in action in a real DeFi use case. And I hope that people will build some cool and interesting project that we didn't even us think about, that will use the autonomous smart contract feature. We can stop also. We can stop also the price variation so that we are not spammed by logs. Stop price variation. That's cool. I just want to showcase a second bot that I have made. I wanted to showcase it also on to live code it, but it will take too much time. But I will showcase a bit the code. It's the same structure as the bot that we made together. We can see that it uses the same constructor function, the same start function with a little bit more other calls, the same stop function. But what does it change in it is that in the advanced function, we are not just looking at the price and say, okay, if it's more than 25, we buy or we sell. We are calculating the RSI, which is the relative strength index, which is a simple index in financial. I don't know every detail of this index, but the main thing that we know about this index is that when it's below 30, we buy, and when it's more than 70, we sell. And this smart contract use the price of the Massa each half of a second, and at certain time it took the last price that he saved and calculate this index to know if you need to buy or sell some Massa. So that's a more advanced version of the bot that we built, but this is like the same structure. You will be able also to fetch the code on the repository. And so that's another example on a trading bot that you can build on Massa, which is a bit more evolved than the one we built together.
Cool. And you said these will both be on GitHub somewhere, right?
Yeah, I will, but I can send you the repo on our chat so that you can link it to everyone right now. I made it public before the call, just so that I don't forget, because I keep saying at the end of the call.
Yes.
Oh, that's not this. That's one of that's the address. This. So the last thing that we need to make together is to upload our little website on Massa directly, so that we can access to this little interface directly on Massa, and our product will become fully decentralized and will not have any centralized points. So to upload a website on Massa, we will use Massa Station, Sula, Massa Station, both name works. And we have a little interface right there, if I click on Web on Chain, where I can provide a website name and a zip that contains all the source code of my website. And this zip will be updated on the blockchain, and this will be the zip that will serve as the source code. So you need to have your index.html at the root of the zip, and after the rest, everything is set up by your index.html. So in my case, the little interface that I have made is right there on the left of the screen. You can see that I have only 3 files. I have made a really simple interface. You have an HTML file, a CSS file, and some JavaScript file to interact with the blockchain to get the balance, etc. And the goal will be to make a zip of this folder. So let's go on. Oh, we are already on interface. We can create a zip with these three files, and we can upload it on the blockchain. So I will call my website Super Rich Bot, because we will be super rich. There is 2 bots because there is a one with RSI also. I can import my website, my little zip, and deploy it to my website.
It said on wallet test. Is that correct, or do you need it to be on build?
Yeah, that's something that we can send. We can create wallets on Massa on Massa Station. Yeah, we can use Massa Station also to create a wallet. Just something that you asked before about the private keys. The only problem is that you cannot extract the private key from the wallet. I think maybe I'm missing something, but I don't know. I think you can just import wallet, but you can't. So I created a wallet just before the call. And so the wallet is now linked to every product that is running on Massa Station. And so I can use my wallet of Massa Station on every product. So one of the products is the deploying of smart contract, and I can use it there. Just there is a problem because I had the page to provide my password and I didn't provide it, so I don't know. Oh, it's there. Okay, so I need just to each time we use the wallet, it just pop up this little. I took too much time to type my password. When you upload a website, we're looking. So maybe I need to restart. That's something that I never made. I will need to
My
pay
fault.
it to the team that is developing Massa Station. Is that when you take too much time to type your password, then it don't work. So let me restart it. Oh, if my computer wants. Otherwise, my computer. I think my computer is tired of the call.
Yeah. Well, nothing was messed up so far, so we had to have one problem. Otherwise, it's not.
It's not very. Oh, it's not very something that the user are making like to wait before typing their password. So I don't think they tested that. But
that's why we're here.
I cannot kill it. I will just close the terminal. Okay, so let's restart. Yeah, everything. So let's restart Massa Station. Directly on the buildnet. Okay, so right now I have my test address. Okay, nothing happened. I will deploy my bot super rich. So yeah, I will use the wallet that I have on Massa. So the password that I made is a very secure password with 4 characters. And this will take a few seconds to deploy the blockchain, the website on the blockchain. So we can see the first step went well. Let's go for the second step. And depending on the size of your website, it will take more time. And also, as the website is stored on the Massa blockchain and the storage in Massa blockchain requires you to lock some coins, the more your website is big, the more coins you will have to lock on the blockchain. So it's not totally free, but it's something that you pay one time. And you are not really paying, because if you delete your website, you will get back the money. It's just like a caution that you give to avoid having too big storage. We are limiting the storage by the amount of coins that is circulating on the network.
Okay, so it's not like gas; it really is locking.
No, it's not gas. It's really blocking. Yeah, you can retrieve it. It's not that you lose your coin. You are just putting them locked for the amount of time you keep the storage. So I can see my website there. I can click it to access it, but we can also see the website there on the list of all websites that is available on the network. So there is a bunch of test websites because there is a CI that is running test website, but we can see our website there. We can try to access it. There is just a little problem because I have made my call in HTTP and not HTTPS. So I just need to, if you develop well and your website use HTTPS, you don't have my problem. But yeah, so right now I'm on botsuperrich.massa directly on my website, on my browser, and I have the same data that we had just before. We can see that it's the same website with the same address because our balance is high and it's not the balance by default. So it's the one that we used just before. It's the same interface, same one as this one. And we have the full website fully running on chain, and we have also a second interface they have made to trigger the RSI bot. It's worked the same as the simple bot that we made, but this is the website totally hosted on Massa on chain. So right now on our little project that we built in 1 hour, we have no centralization point. Everything is on the blockchain. The smart contract wake up himself in the future, and the front end is also on the blockchain, and you can access it on your browser as soon as you run Massa Station. So that's really nice.
If I were running Massa Station now, pointing it to BuildNet, which I wouldn't be, but if I could run Massa Station pointing to BuildNet, I could also type botsuperrich.massa and I could access it right now, right?
Exactly. Yeah, everyone, cool. If you download Massa Station and you run it with this command, Massa Station not server buildnet, and you go to the registry, you will be able to find my little website, and you can yourself start the bot, stop the bot, stealing my money, everything, because I have put no secures. And maybe we will not go in vacation after all, but you can try it on yourself on the BuildNet if you want, of course.
Great. Super cool. I really, I knew that we had the ability to do timed smart contract calls, but really want to dig in later on what it would mean to be able to build smart contracts that can react to changes in other contract addresses. Very powerful.
Like for example, if you trust someone that he will give you soccer results each day, you can just subscribe to this man and some addresses, some specific match that he can provide to you. And when the score is moving, you can, for example, change your bet or something like that. You can do much things. Like there is so much idea that could be bringing up. The only thing is that you are limited to things that happen on the blockchain, because the blockchain is like a controlled environment, fully deterministic. So you cannot you cannot rely on something that is on the internet. You are close to the blockchain, of course. But as soon as the data arrived in the blockchain and you trust the data, the person that gives you the data, then you can make really whatever you want. Really, it's really powerful.
Very cool. Well, thank you so much. Maybe I will put up the demo URL again if anyone wants to look at the demo.
Do not hesitate to check it out. And if you have questions after the talk, or if you see this on YouTube after the live in VOD, you can just ask questions on YouTube. I will try to check them, and also you can open issue on the repository with the example. If you have questions, you can open issue. Don't worry, I will be really happy to help you on that. And you have our Discord also, where we have a big, not that big, but a community that is currently being built to create smart contract on Massa. We have a bunch of builders that already create some smart contract on Massa. I saw someone on the chat, which name is Altai, which is one of our most active community member that build a lot of cool projects around Massa. So if you want to try to develop your own smart contract and you have some problems, or you just want to connect with other builders, you can join our Discord.
And to find the Discord is the best way to just go to the Massa website?
Yeah, the best way is to go to massa.net. You will have all the information. I don't know why I'm... Okay, there is Chinese translation. I didn't know. You will have all the information. You can fetch all of our social network, and you can find the Discord there.
Okay. Well, thank you. And I guess we will let you go and enjoy the rest of your rainy day in the south of France.
Yeah, sadly, it's not a good day to go out, but let's hope tomorrow it will be better. Thank you for having me presenting the smart contract, and I hope everyone had a great time.
Thank you.